Hi, welcome. I'm trying to learn electrical engineering today, domestic use of electric heating, and after we've done it, we call it to wrist training. And if you participate in the wrist training, then this will be on risk. Domestic use of electric heating. Lamps, fires, irons, and kettles are all familiar to us. Most homes contain these items. These appliances are always connected in parallel in the home. Each single lamp or heater is connected directly to the mains so that the full mains voltage is applied to it. There is one exception to this practice: the heating elements in boiling rings and electric ovens are controlled by a switching system which can connect the elements both in series and parallel. Such switching have markings low, medium and high. Are we saying here that something's working with making this electricity, this current into series instead of parallel, when we are saying low, medium, high? Okay. Fuse. You should know that all electrical appliances must be fitted with a fuse. I don't know what a fuse is. Which will melt should a larger current flow than it usual for the appliance concerned. Okay, fuse. So it's too much power on it. But it's a fuse. Fuse wire is used in two ways: either fitted in porcelain. Do we mean the stuff out of which some plates are? Porcelain holders in a fuse box, or in the small cartridges, I don't know what they are, used in ring main plugs. Okay, there are some fuses, and they are melting if the current is too large. And with fuse wire is used in two ways: inside of porcelain holders, inside a fuse box, or in small cartridges in ring main plugs. Miniature circuit breakers are now coming into use as an alternative to fuse in domestic circuits. The book is from the 60s or something. Miniature circuit breakers are now coming into use as an alternative to fuse in domestic circuits. These, shown in figure 52, automatically disconnect any circuit when it becomes overloaded. The circuit breaker can be reset immediately by pressing a button or a switch, an even simpler operation than replacing a fuse wire or cartridge. Okay, a fuse wire or cartridge. I think I know what a fuse wire is. A fuse wire, that is a wire between the two currents. So the current comes in from the mains and goes into the lamp, and in the middle there's the extra fuse wire. And if the charge is too big, the current melts and it breaks down the bridge. And there's no longer current flow because the cable is burnt out. And it has to be replaced. And the miniature circuit breaker, whatever, a little circuit, and that is also breaking or something. No, but it's a thing. And the circuit breaker is just too much power onto it, and then it goes out, but it can be just snapped on again or something. The circuit breaker can be reset immediately by pressing a button or a switch, an even simpler operation than replacing a fuse wire or cartridge. Contrary to the popular opinion, a fuse wire is not intended to have a high resistance. It is usually of tinned copper, which as you know is a good conductor. Its function is to become hot enough to melt and vaporize if the current through the fuse becomes larger than a certain value. Okay, the idea is not that it has a high resistance, so the idea would be when that bridge holds only sounds, but there's a high resistance, so the idea is it's like a stop lock. If it comes too much, then it would just slow it down, it would decelerate it, because it won't come through. It is not the case. It is so that it comes through, it is tin, or what was it here? It is tin copper, and it will melt. It is even good currenting, good conducting. So it is good conducting, so that it becomes so hot that it melts. There is one practical problem. How does it even happening? With something that's suddenly too much. There is one practical problem most householders meet with it rather puzzling. Okay, there's a puzzling problem for householders. Appliances are usually rated in watts or kilowatts. You will know what a 100 watt lamp looks like, and you will probably know a single bar electrical fire. It's usually rated at 1 kilowatt. A single bar electric fire. Okay, let's just say two different types of lamps. Fuses are rated in amperes. So what the fuse, the wire in the center which the short lamp holds out, is rated in amperes. Cartridge fuses are marked 3A, colored blue, or 13A, colored brown. At one time, other values were used too. 2A, 5A, and 10A were common, but their use is being discontinued. What value of fuse should be used with a particular appliance? The first thing to note is that an extra item of information is needed before the question can be answered, as was made clear on page 61. We need to have two numbers, was said, two things. This is that the value of the mains voltage. This is that the value of the mains voltage for which the appliance is designed must be known. The following examples will make the procedure clear. Okay, nowadays, how much it should use or something or something. Example 1. A lamp is marked 240 volt, 100 watt. 6 such bulbs are used on one lighting circuit. What fuse value is required? Having watts equals volts times ampere. So we're having 100 watts, and that equals the volts, 240, times the current in amperes. And the current is the watt divided by the volt, multiplied with the amount of ampere in each bulb. So 6 bulbs will use a current of 600, so 6 times 100, 600, divided by 240, the amount of voltage, multiplied with ampere. In example, R is 2.5 ampere. Therefore, in practice, a 5A fuse wire would be used. This is the thinnest fuse wire usually sold for use in fuses. Okay, we know what we need. We have to have a 5A fuse wire because the 5A would burn through by 5 ampere, and our bulbs have 2.5. So if it goes to 5, that wire burns. What is it even happening? Are we not going the lamps then broken, or what is the fuse doing? Whom is the fuse helping? Example 2. An electric steam iron is marked 240 volt and 1000 watt and used on a ring main circuit. What type of cartridge fuse should be placed in the plug? Watts equals volts times ampere. 1000 watts, that is the amount of which the iron is using. So the iron to make clothes, I think is good. To make clothes clean. Now clean straight. 1000, that is the iron using, and then 240, that is the amount of which the power is from the main supply. We multiply it with the current in amperes. And the current is 1000, the amount which the iron usage, divided by 240, the amount of power. These are 4.16 amperes. A 13A cartridge should be used in the plug, or a 5A if available. Why should we use a 13 and not a 5A? Because cartridges are 3A and 13A. Whatever, so 5A would work also same way, but 13A would be our second option, which is the first one is it. If you have not already done so in your earlier work, see Science Through Experiment 2. Somewhere. Pages 190, 192, this book has just 80 pages, so not here. You should make a careful study of the various safety precautions employed in domestic electrode circuits, having particular regard to the placing of switches, fuses, and each connections. Okay, that was the electrical engineering part, and the last part I said, don't play with your electricity. If you were your electrical engineering, you can go directly to the next part of electrical engineering, where we will continue with electrical engineering. If you stay here and participate in the Wristtraining, that is at your own risk. Hold a stable standing stance, arms up, so fists, and bring your fists down. And now fists again, and up in. After spotlight, the flashlight. And now the magician, flat hands, and in and out. We're having 3 rules. Flat hands and up. pancake flipper. The first rule is that you're stopping immediately as soon as there's pain. Hands out, flat hands, and down and up. And the second rule is that we are going only as far as you can go with a little bit of effort. The quadrangular castle architect, fists in, up, out, down, in, and back. And the third rule is that you're not overdoing it. We just want to strengthen, not to exhaust. You can take a break whenever you want. The fist, and bring it down and press on the inside. And from the outside. And behind, fist, and down. And now the T-Rex in the gym. You can use a tennis ball if you like. Press onto it and release. And again, release. And again, switch. Press again, release. Press. Press. And now the cautious big bang. Fingertips of one hand on top of the fingernails of the other hand. And open, close again. And change, open, and close. And now the field is new synthesis director. Both hands the fists, open and flare the fingers. Close and flare. And now both hands up with best bridge and bend the middle knuckles. Again, and bend at the knuckles. One more time. And open. And now the frog testing the water temperature. You can take a break if you like. Hands and down the flat fingers. And up. Down. And up. Last round. And now both hands up. And flare. Now. Then claw the fingers. And spread them apart. Open. Claw and flare the fingers up. But claw. Open one more time. Claw and flare them apart. Open. One hand out. Try to flex the biceps. If it's possible. And press against the fingers. And now the other hand out. Try to flex the biceps. And press against the fingers a bit. And both arms in, strong fists, into flexion, out into extension with flat fingers. In, strong fists, flexion, out extension with flat fingers. One more round. And now the fists up, into flexion, down, strong fists, and down. Turn it around. And again down, again around, and now the Isaacs. Flat hand, bend knuckles and press into all four fingers. And switch. The other hand, fingers down and press into all four. And I think last exercise, no, one more, the sundial. You have a sock or something with a long arm out. Hand into flexion, let it fall down, and try to catch it again. Wander slowly in the front. And on the other side. And now the last exercise, the rocket boosters launchers. Long arm, strong fists, and bring the fists into flexion. Without extension, flat fingers. In, strong fist, flexion. Out extension, flat fingers. In, strong fist, flexion. And again. And now go with moderate pressure over the middle part of the lower arm. And on the other side. And that was the wrist training. I thank you very much and until next time.